So this is our third and final behind the scenes video of the Damage Dice Explained to show you how I made the graphs for that video. The way we've seen before is we use this function MakeStats, and this is the thing that loops over all the possible roll combinations and then evaluates the probability of each result. This function starts in line 63. It's got some declarative stuff here at the beginning. It takes a look at all of the dice so that it knows what the maximum possible roll is. And then we set up this stats list where you have the possible roll results, so everything from minimum roll to maximum roll, going to, and then we count the number of times that each of those values happens. In line 75 here, we call this other subroutine loop over dice. What loop over dice does, if you scroll up here at line 31, this is the function that examines each of the dice we have in dice list, and it loops over each one of those die. So it goes through some, so basically this is just some bookkeeping stuff to keep track of what it is we're rolling. So this is where the file name comes from that it exports to. This is also where the legend name comes from. So when we loop over a single die, what we're doing is we're saying, I want you to tell me everything you can about the possible rolls of that die. So for example, here, if you are going through, so let's say for example, you're rolling a D12. What you would do is you would add 1 to each roll each time. So you would go 1, 2, 3, 4, etc., up to 12. Now, you don't know how many, when this program runs, it doesn't know how many dice you're going to input. So this is a recursive subroutine that calls itself down here. So what it does is if you're at the end of the dice list, so if the die you're on right now is the last die in the list, then it just loops over the possible roll results of that die and adds them to the total. Otherwise, it loops over the rest of the die, so it starts at the next die in the list and starts to loop over those. And what you get is this loop over die being called again. So this function calls itself until it ends up at the last die. And the way it keeps track of all of that is it's looking at the current roll of the die you're on, and then adds that to the, actually that's this one right here, isn't it? It looks at the current roll of the die you're on, and then adds that to the total for next time. So this is a wonderful little recursive code that keeps calling itself until you get down to the last die in the list. This took me a lot of trial and error to put together. There might be a more efficient way of doing that, but this is the way I found that guarantees you get over all the dice in the list. So that's where all the actual math takes place. The rest of it is mostly bookkeeping after this loop over dice. We make the file name, we look at the total results. This is where we calculate the standard and deviation of it, the average and standard deviation of everything. And then of course we create the graph down here. We say, okay, now I want you to make the graph using the, so this is set up as a gdots up here. So gdots has an argument called .plot where you put in a list and it gives you a graph with those data points. So, and then of course here we write out to a file where you can export the, well, it exports for you the roll results, the histogram, and then you can import that into your favorite spreadsheet program. So that's what happens every time we call this MakeStats command. It's looping over each of the dice that we input. It's calculating the total for each possible combination of rolls, and then it's reporting the frequency with which each of those happens. And then we multiply it by 100 so that we're dealing with percentages there. So that's how the MakeStats function works. And that's how I got the graphs for Dice Damage Explained. So again, you know, if you play around with this and you find some interesting combinations, let me know in the comments below. And we might do another follow-up video looking at some interesting combinations. Coming up next for Dungeons and Divisors, we're going to use the same code to look at some of the differences in how you roll critical hits, or damage for critical hits, I should say. So when you roll critical hits, you're supposed to get a multiplier for your damage roll, but a common misconception is that a lot of people think you're supposed to double the amount of damage, not double the number of dice rolled. And we're going to take a look at what those two different interpretations do to the histograms here and how that changes your odds of getting a good amount of damage. So again, thank you so much for watching. I will see you next time. Bye-bye.